there is a type of vector field you've already seen a couple chapters ago, and it has to do with this definition. A vector field F is conservative if there is a scalar function f of x, y, z, such that you can take del little f, that's the, little f stands for the scalar function. You can take del little f and get the vector field. Okay, so del little f, another way we've used to represent it is like this. Remember this symbolism? That's called the gradient, right? Gradient of f. And del f, remember, is the partial with respect to x times I plus partial with respect to y times j plus partial with respect to z times k. Or if it's just two components, it would be f sub xi plus f sub yj. Let's find the gradient vector field of f of x, y, z equals the square root of x squared plus y squared plus z squared. Remember, to find del f would be f sub xi plus f sub yj plus f sub zk. So it's like you're back in chapter 14. We're going to find the partials, right? Okay, so what would the partial of f with respect to x be? So you could think of this function, you guys, as x squared plus y squared plus z squared to the 1/2. So what would that be? It'd be 1/2 times the quantity x squared plus y squared plus z squared to what exponent? Negative 1/2, right? Subtract 1, and then multiply by the derivative of what's inside by the chain rule, which would just be 2x. Or the 2's would cancel, and you could write this with x on top over x squared plus y squared plus z squared to the 1/2, but it's kind of nice to write that as a square root. Square root of x squared plus y squared plus z squared on the bottom. Now, can we use kind of a symmetric argument to get the partial with respect to y? What would be on top? Y over that same square root. And what would be on top for the partial with respect to z? Z. So then your gradient vector field, del f, would be just, put I, j, and k in front of these partials and then add them together. So it would be x over square root of x squared plus y squared plus z squared times I plus y over the square root of x squared plus y squared plus z squared times j plus z over the same square root times k. Now, I didn't put del f of x, y, z, but I think that's clear from the context what the inputs are. So that technically is a vector field. It's a very special vector field. Conservative vector fields are very special.